Okay, so today we are starting a new unit and we are talking about rational exponents. So rational means a fraction. So guys, circle or underline this word. This means a fraction. Underline this word radical. Radical means the square root symbol. We call that symbol a radical, okay? So what we're going to do today is we're going to convert radicals to rational exponents. And you know, exponents are these, say I have x, this is an exponent, okay? However, we're going to have rational exponents, meaning it's going to be a fraction exponent, okay? That's what we're going to look at today. All right, so this is the rule. It's in the box. This is the rule that we're going to be working with today. Notice the numerator, it represents the power. It goes inside of the square root or it goes on the back. You guys see where the position P goes? Okay? R represents the root. That goes in the front, right there. Okay? So let's do an example. Let's do example A. According to our rule over here, we're going to have a square root. The numerator represents the power. It goes in there. The denominator represents the root. It goes on the outside. Okay? Let's try a next example. You're going to have square root, or let's actually skip B for now. We'll talk about that next. Let's do C. You're going to have the square root of X. The numerator is the power. It goes on the inside. The denominator is the root. It goes on the outside. So that is how you would write it. All right, let's do example D. We'll have the square root of 64. On the inside, the numerator goes on the inside. I'm sorry, I put 64. That's supposed to be a 6x. Okay? And the denominator goes on the outside. Now, one little thing I'm going to add in here, I'm going to put parentheses so that the power of 3 doesn't just go to x. It goes to the 6 and the x. So just put that in parentheses there. Okay, so do you guys see how I went from an exponent to the radical using that rule?
Yes.
Okay. All right, now let's go backwards. We're going to go this way from the radical to the rational exponent. So, guys, let's look our attention up here real quick. I want to make a comment. Do you have to write the ones in math? Okay, so this one right here, I'm talking about this one right here. We don't have to write that, okay? So I'm going to get rid of that one. And whenever we're doing radicals, you do not have to write the 2 on the outside. You don't have to write that 2, okay? So that means this example will look like that. Simply that. Okay, so on the top of your paper, whenever you have x to the 1/2, it'll just be a plain square root of x. You don't have to write the 1 on the inside, and you don't have to write 2's that are on the outside, okay? All right. So looking at example E, they did not write the 2 on the outside because remember, we don't have to write them, okay? So let's go backwards. The power goes in the numerator. The root goes in the denominator. Example F, we have 3x. The power goes in the numerator. The root goes in the denominator. So this is your answer. Okay. Now, let's go back to letter B real quick. In fact, before we talk about B, let's do some more examples real quick so that this can sink in. Let's say I have x to the 9/5. How would we write this? Where would the 9 go? Inside. And the 5? Outside. Okay. Now let me add something new. Okay. Let's say I put a negative right here so that it's a negative fraction. The way your answer is going to change is you just put it in the denominator. Okay? So let me give you another example. Let's say I have x to the 4/3. You would write this as, the 4 would go on the inside, that's your power. 3 is your root, that goes on the outside. Now, if I turn this into a negative fraction, turn it into a fraction and it's going to be in the denominator. Okay? So, knowing this example, let's go back to our notes. Okay, right over here, answer choice B. First of all, where would we put this? You have a 9 on the inside. What goes on the inside? 1 and a... Do you have to write the 1s and the 2s? No. So I'm going to erase the 2 on the outside, and you don't have to write this 1 that's on the inside. Okay, and there's a negative there. Yes, so I'm going to write it like this. I'll just put a -1 right there. You write it like this. Okay? Whenever you have a negative exponent, it just goes in the denominator. Okay, let's try G. What is it missing on the outside that it normally has? A 2. And what's on the inside that it normally has? A 1. So that means 1 is in the numerator, 2 is in the denominator. And since it's in the denominator, we know it originally was in the numerator. So that's how you do G. Okay, let me do some more examples just so that it sinks in. Let's say I have a to the -3/2. We'll have square root of a. Where does the 3 go? Right here. The -3 goes here. And what goes on the outside? 2. A 2. Do I have to write the 2s? No. So I don't have to write the 2. And whenever I have a negative, we just put it in the denominator and it gets rid of the negative. Okay? You can skip this step if you don't want to. You can jump from here to here. Okay. So I'm going to let you guys do these examples. So I want you guys to try A, B, C, and D. Okay. So the numerator goes on the inside. The base goes on the outside. You guys can also write it like this, where the 2 goes on the very end. Okay? You can also write it like that. You'll see it both ways. Okay? This one, 7 goes on the inside, 4 goes on the outside. You can also write it like this. You will see it both ways. Okay? All right, now we're going to exponential form. We're going to get an exponent this time. This will be z. 2 is in the numerator, 3 is in the denominator. Here, we're going to have c. This was -5/3. Okay. You can also see it written like this, or 1/c⁵. Exponents become positive when you put them in the denominator. Okay. So it can be this or that.